The story of Dragonslayer begins with the legend of Beowulf, a mythical hero who perishes while slaying a ferocious dragon.
During the fight, Beowulf's sword shatters on the dragon's hide, and he resorts to using his seax knife to kill the beast.
We thought it would be a cool project to recreate Beowulf's seax using modern steels that would not undergo catastrophic failure during the battle.
Dragonslayer is made from Therium C61 and C64 steels, two case-hardening steels computationally designed by Questech Innovations LLC. The cutting edge of the blade is made from carburized C64, the harder of the two steels, while the core is made from C64 pattern welded with C61, the tougher of the two steels. Having such a hard cutting edge with a tougher core allows the blade to pierce hard materials while at the same time absorb large forces without fracturing.
Our seax is a pattern-welded blade for both historic and literary reasons. Beowulf was written and takes place between 500 and 1000 AD, and pattern welding is a feature seen in many European blades of that era. Additionally, several blades in the text are described as being wave-patterned, in reference to such forge welding, making the Dragonslayer fit seamlessly into the world of Beowulf.
To forge Dragonslayer, our artisan bladesmith, Rick Furrer, heated ingots of C61 and C64 steel and flattened them using a power hammer, hydraulic press, and roller. He then cut the ingots into 8 smaller bars, 7 to become a billet for pattern welding, and 1 bar of C64 to become the blade's cutting edge.
Because of the high chromium content in Therium steels, Mr. Furrer had to devise a very unconventional method for welding the bars together. To respect the privacy of his intellectual property, we did not include further footage of the forging.
High chromium steels resist welding because they form chromium oxides, which are too stable to be reduced by conventional boride fluxes. Mr. Furrer devised a solution by placing the billet inside a mild steel pipe and filling it with kerosene. As the pipe was heated and hammered, the kerosene ignited, creating a high-pressure, low-oxygen environment. This allowed any oxides that formed to be reduced by carbon monoxide so that the welds would hold.
After being removed from the mild steel pipe, the laminate was again cut into smaller bars. Some of the laminate was twisted and then ground to produce the star pattern, which was then welded to the remaining laminate and to the C64 cutting edge. Mr. Furrer then heated the steel past its austenite finish temperature, making it a solid solution. He then hammered it into its rough shape before finally grinding the blade into its final shape.
Since Therium C64 is a case-hardening steel, its strength is maximized when it undergoes carburization. Dragonslayer's C64 cutting edge was carburized to a case depth of 55 HRC at 10,000ths of an inch. Upon reaching the solutionizing temperature of 1832 degrees Fahrenheit, carbon atoms diffused into the iron lattice. The blade was then gas-quenched at 2-bar pressure to cool the steel below its martensite start temperature, causing a diffusionless transformation from austenite to martensite.
Because Therium steels have a martensite finish temperature below the freezing point of water, a small percentage of austenite is typically retained after the gas quench. To ensure the complete transformation of the retained austenite to martensite, the blade went through a cryogenic treatment by immersion in liquid nitrogen for about an hour. It was then air-warmed to room temperature.
The primary strengthening mechanism in Therium steels are M2C carbides, mainly chromium and vanadium carbides, with lesser concentrations of molybdenum, tungsten, and iron. The blade was tempered above 900 degrees Fahrenheit for 8 hours to nucleate and grow the M2C carbides. It was then air-cooled to room temperature, leaving it fully martensitic with optimally sized M2C carbides, ready to withstand a dragon's fiery breath.
Finally, the blade was polished and the pattern-welded section was etched to bring out the contrast between the C61 and C64 steels. We mixed our own Ralph's reagent and then immersed the blade for 25 seconds to reveal the pattern you see now.
We constructed the hilt from a piece of bog oak dating to 3300 BC, a material that would have been around during the events of Beowulf. Similarly, copper was chosen for the crossguard and pommel because copper fittings were being used on weapons from that era. One of Beowulf's sword hilts is described as being decked with dragon shapes, with a sword guard of bright gold rightly marked in rune letters, so we have incorporated these same elements into our own hilt.
The completed seax looked fit for a hero.